Welcome to 3.3, Finding the pH of weak acids and bases. You need to look at textbook pages 36 to 38 to help with this. The lesson objectives for today are to know that weak acids and weak bases dissociate only slightly in aqueous solution, be able to construct an expression with units for the dissociation constant Ka for a weak acid, know that pKa equals minus log 10 of Ka, and be able to perform calculations relating to the pH of a weak acid, to the dissociation constant Ka and the concentration. So, first point is that weak acids and bases are not fully dissociated, which you're probably aware of already from your GCSE work. So when we talked about strong acids in a previous lesson, we assumed that 100% of the acid had dissociated. So that for every HCl, for example, you would have one H+. However, for weak acids, less than 1% is dissociated. In some cases, a lot smaller than that. So, in this case, we can't assume that they're fully dissociated for the purposes of calculation, so we have to do something differently. Now, it's important to remember with this work that there is a difference between strength and concentration. So the strength of the acid is how dissociated the H+ is from the molecule, and the concentration is how many of those acid molecules are in a certain volume. So because we've got a weak acid and because it's not fully dissociated, then we've got an equilibrium going on. So we can use an equilibrium constant to represent the dissociation of acids, just like we did when we did the equilibrium unit. So for our reaction HA going to H plus A minus, and apologies for the arrows there, but I can't do a proper equilibrium arrow, but you all know how it should be. So for that reaction, our Ka expression would of course be the concentration of H plus times by the concentration of A minus, and then the whole thing divided by the concentration of HA. Because when we write our equilibrium constant, remember, it's the concentration of the products divided by the concentration of the reactants. Now in this case, there were no powers involved because there's 1 mole of each substance. But remember, if you had more than 1 mole of those reactants or products, then you would have to have those concentrations to the power of how many moles there were. If you need a reminder of that, then go back and watch the equilibrium videos. So for acids, we call this equilibrium constant Ka. So the eagle-eyed amongst you might have noticed that normally we would call it Kc. In this case, we've written Ka. That's not a mistake. When we're talking about acids, we call it a special case, so we call it Ka. And the larger Ka is, the more dissociation is going to be. So the bigger Ka is, the stronger the acid is going to be. And it's important to note that as for a normal equilibrium constant, the units depend on the equilibrium expression. If you need a reminder how to do this, then look back at the previous videos or in your textbook. So now we need to talk about how to calculate the pH of weak acids. So for strong acids, we assumed 100% dissociation. We can't do this for weak acids because, as I've already said, it's less than 1%. So instead, we have to use the equilibrium constant. So if we go back and look at this expression that we've just written on the previous slide, we had Ka equals H plus times by A minus divided by the concentration of HA. However, we can simplify this expression because each HA that dissociates is going to produce the same number of H pluses as A minuses, which we can tell by looking at the chemical equation. HA goes to H plus A minus. So because H plus is going to be the same as A minus, the concentration of it, we can simplify the expression so that Ka is equal to the concentration of H plus squared divided by the concentration of HA. So if we then want to rearrange and find out our pH, then we can find the concentration, because the concentration of H plus squared is equal to Ka times by the concentration of HA, so we just rearrange that expression. So H plus then is equal to Ka times by the square root of HA. And once we know the H plus concentration, we can then work out the pH, because remember pH equals minus log 10 of H plus. So you can see it's still quite a simple calculation, it's just a bit more difficult than if we're talking about strong acids. Now another thing you need to know about is pKa. So you will see this expression written as pKa. And students get very confused about this, but it's quite simple. pKa is equal to minus log 10 of Ka. So in the same way that pH is minus log 10 of the H plus concentration, pKa is minus log 10 of the Ka. And the smaller pKa is, the stronger the acid is. And the larger the pKa is, the weaker the acid is. And this follows on from when we were talking about Ka on the previous slide. So here are our lesson objectives again, which were to know that weak acids and weak bases dissociate only slightly in aqueous solution, to be able to construct an expression with units for the dissociation constant Ka for a weak acid, to know that pKa equals minus log 10 of Ka, and be able to perform calculations relating the pH of a weak acid to the dissociation constant Ka and the concentration. So as usual, if you feel you've met these lesson objectives, then that's great. If not, then you need to go back and either watch the video or look at textbook or online notes to make sure that you fully understand these before you come to lesson.